Welcome everyone. Today we shall study about basic principles of metallurgy. So student, this is from lesson metallurgy, and student, we have studied about physical and chemical properties of metal as well non-metal, and we have seen the different reactions of metal and non-metals with another substance. So just check out my description box. You will get all the links of that videos, and this is for class 10 part 5 video of this lesson. Right? Okay, so first we will study about what is metallurgy first. Okay, so what is metallurgy? So this is metallurgy is a science and technology regarding the extraction of metals from ores and their purification for the use is called as a metallurgy. That means it is simple words. This is a process in which the metal is extracted in their pure form by using different methods. So we shall study the different methods of purification in this video. Alright. So first let us study the occurrence of metals. So most metals being reactive do not occur in nature in free state but are found in combined state as their salts such as the oxides. So you can see the aluminium oxide, ferrous oxide, chromium oxides and their carbonates form and sulfides and their nitrates form. So these metals are reactive, so they do not occur in nature in free state, but they will find in the combined state. That means they will find in some of the like oxides, carbonates and nitrates. In this form they will present. And however, the most unreactive metals that are not offered by air, water and other natural factors, that means the unreactive metals will not react with or not combined with air, water and other natural factors. So like silver, gold, platinum generally occur in their free state. So they will not found in the combined state. So like gold, platinum and silver, these are occurring free state, and the compounds of metals that occur in the nature along with their impurities are called as minerals. And the minerals from which the metal can be separated economically by using different methods are called as ores. So we have seen the combined state, free state of metal and the minerals. What are the minerals? These are the occur in nature along with some impurities, and the impurities are called as ores. And from the ores metals can be extracted or separated. So these are the minerals and ores. And ores contain many types of impurities such as the soil, sand and rock substances along with the metal compounds, and these impurities are called as gangue. So you can observe the rocks containing the different containing metals with different impurities. So these are the gangue. Alright. Now, student, metals can be extracted from their ores by means of a different various methods of separation, and the process of extraction of metal in pure state from the ores is also a part of a metallurgy. And ores are taken out from the mines, and the gangue is usually separated from the ore at the site itself by various methods. That means ores and gangue can be separated to extract the metal in their pure form by using different method, and then the ores are carried out to the place where metals are produced, and their metals are extracted in pure form, and then metals are further purified by different methods of purification, and this entire process is called as a metallurgy. So we'll see how different methods are used to separate the metals from their ore, and how ore and gangue are separated by using different methods. So let's study. Okay, so here we have the basic principles of metallurgy. That means pure metal is obtained from the ore by the following stages. So first stage is concentration of ore, and next stage is extraction of metals from their ore, and then refining of metal. That means in refining of metal, the pure form is metal can be obtained. So these are the three principles of metallurgy, and out of this three, today we shall study only about one principle, that is concentration of ores. So let's study. Okay, concentration of ores. So here also there are different methods are there. So first of all, student, what is concentration of ore? So the process of separating gangue, so gangue are the impurities which are there in the ores of minerals. Okay, so the process of separating gangue from the ores is called as a concentration of ore. And in this process, the concentration of the compound of the desired matter is increases, and various ways are used for this purpose. And however, exact way to be used depends upon the physical properties of the metals present in their ores and the gangue. So that means the physical properties and their reactivity, the different methods are used to separate the metals or to separate the ores and gangue from the metal. And it also depends upon the reactivity of the metals and the facilities available for the purification. So based on their physical properties, reactivity, different methods are used for purification or for their concentration. It means separation of ore from gangue, separation of gangue from the ore. And various factors could be responsible for the environmental pollution are also considered. It means here different factors like reactivity, physical properties and environmental pollution also considered to select the proper method of concentration of ore. Okay, so student, some general methods for concentration of ores are as follows. So first is a separation based on gravitation. Next is magnetic separation method, and froth flotation method, and fourth one is a leaching method. So student, these four are the methods of separating gangue from their ores. So let's study one by one. Okay, so first method is a separation based on gravitation. So student, in this method this gravitational method is used for the concentration of denser ores from the water soluble and lighter impurities gangue. That means the gangue will be water soluble, so they will get dissolved in the water, and from then ores can be easily separated out from the solution. Okay, so the heavy particles of ores, that is denser particles of the ore, can be easily separated from the light particles of the gangue by the gravitational method. So the light particles can be easily dissolved in the water, and then ores can be easily separated out from the gravitational method. And the process to carry out this separation are as follows. So here two processes are there. First is a Wilfley table method, and second is a hydraulic separation methods. About the Wilfley table method. So student, in this method of separation, so this is a diagrammatic representation of the Wilfley table method. So in this method of separation, the Wilfley table is made by fixing narrow and thin wooden riffles on inclined surface. You can observe the slits. Okay, so these are the wooden slits, and the table is kept vibrating continuously just to separate the ores. And powdered ore are obtained from the lumps of the ore using ball mill is poured on the table, and a stream of water is also released from the upper side. So this is a stream of water which is released in upper side where the powder ore has been kept. So as a result, the lighter gangue, that means the density gangue with density is very less, particles are carried away along with the flowing water, while the heavier particle, in which the proportion of mineral is more than the gangue, okay, and proportion of the gangue is less, are blocked by the wooden riffles and get collected on the slits between them. So you can observe the slits. So in between the slits, the denser particles of ore can be easily collected, and then it is separated easily. So this is the Wilfley table method. These are the two pictures I have kept on the screen so that you can observe the proper industrial arrangement of the Wilfley table method in real. So these two are the industrial setup of the Wilfley table method. And next type is a hydraulic separation method. So what is it? So student, the hydraulic separation method is based on the working of the mill, and there is a tapering vessel similar to that used in the grinding mill. So you can observe the tapering like grinding mill. That means at the lower and the surface is the object is narrow. Okay, and it opens in a tank container that is tapering on the lower side, and the tank has an outlet. Tank has an outlet for water on the upper side and a water inlet on the lower side. Okay. So you can observe the water outlet and inlet in the tank. And finally, ground ore is released in the tank, from the upper side of the tank, and a forceful jet of water is introduced in the tank from the lower side, and gangue particles are lighter and therefore they flow out along with the water jet from the outlet on the upper side of the tank and get collected separately. And at the same time, the heavy particles of the or the denser particles of the ore are collected at the bottom from the lower side of the tank. You can observe the concentration of the ore, okay, lower side of the tank. And in short, this method is based on the law of gravitation. That means the denser particle will be collected easily, wherein the particles of the same size are separated by their weight with the help of water. So these two are the methods of separation based on the gravitation. Okay, now next method of concentration of ore is the magnetic separation method. So what is this? Okay, so this is a setup of magnetic separation method, and this method requires an electromagnetic machine. So here the electromagnetic machines are used. You can observe the roller, conveyor belt. Okay, so the electromagnetic machines converts mechanical energy into an electrical energy by using the magnetic field. And the main parts of this machine are two types of iron rollers and the conveyor belt moving continuously around them. So you can observe easily the circular disc shaped magnetic roller and the conveyor belt around them. And one of the roller is non-magnetic and another is electromagnetic. And the conveyor belt moving around the roller is non-magnetic, made up of a leather or brass. So this conveyor belt made up of this is a non-magnetic and it is made up of a leather or brass. And the powder ore is poured and the powdered ore is poured on the conveyor belt near the non-magnetic roller, and the two collector vessels are placed below the magnetic roller. So this is a setup of magnetic separation method. Now let's see how this works. Okay, so the particles of the non-magnetic part in the ore are not attracted towards the magnetic roller, and therefore they are carried further along the belt and fall in the collector vessel places is away from the magnetic roller. And at the same time, the particles of the magnetic ingredients of the ore stick to the magnetic roller and therefore fall in the collector vessel near the magnetic roller. So this is how the non-magnetic ingredients and magnetic ingredients are collected in separate vessels. And in this way, the magnetic and non-magnetic ingredients in ore present in the ore can be separated depending on their magnetic nature. And student, for example, the cassiterite is a tin ore and it contains mainly the non-magnetic ingredient, that is stannic oxide, that is SnO2, and the magnetic ingredient, that is ferrous tungstate, that is FeWO4. So these are collected by using the magnetic separation method, and these are separated by the electromagnetic method. That means electromagnetic machine has been used to separate the gangue from the ore. Okay, now another method of separation concentration of ore is froth flotation method. So again, this is a setup of a froth flotation method, and the froth flotation method is based on the two opposite properties, that is hydrophilic and hydrophobic of the particles. So this method is based on hydrophilic and hydrophobic properties of water, and hydrophilic molecules get absorbed or dissolved in the water, while the molecules which are hydrophobic molecule only dissolve in oil based substances. So you can observe the alongside diagram, we are using the water and pine oil. Okay, so the substance of molecules which are hydrophilic, they will dissolve in water, and the substance or molecule which are hydrophobic, they will dissolve in oil based substances. That is any oil we are using, like pine oil or eucalyptus oil, any oil we are using. And here the particles of the metal sulfides due to their hydrophobic property. Now hydrophobic, that means they will dissolve in oil. Okay, so hydrophobic property get weighted mainly with the oil, that is pine oil we are using in the experimental set in the set machine. And while due to the hydrophilic property, that means the substance which will dissolve in the water, the gangue particles get weighted with the water, that means they will dissolve in water. And by using these properties, certain ores are concentrated by the froth flotation method. That means ore will be separated from the gangue by using the froth flotation method. Okay, now let's see the working of this. Okay, so in this method, the finally ground ore is put into a big tank containing an ample amount of water. It means in the tank there is large amount of water is there, so powdered ore has been inserted into the tank containing water, and certain vegetable oil such as a pine oil, eucalyptus oil is added in the water for the formation of the froth, and the pressurized air is blown through the water, and there is an agitator rotating around its axis in the center of the flotation tank. Now what is agitator? So agitator, it is a device used to stirring the liquids into the tank. And okay, and the agitator is used as per the requirement, and bubbles are formed due to the blown air. You can easily observe the bubble in the flowing tank, brown colored bubbles, and due to the agitation a foam is formed from the oil, water and the air bubbles together, and due to agitating, and this foam rises to the surface of a water and floats. You can observe the froth, okay, froth or foam. So that is why this method is called as a froth flotation method, and the particles of a certain sulfide ore float with the foam on water as they preferentially get wetted by the oil. That means they will dissolve by the oil, they will be easily separated. These are the concentrated sulfide ore, and the below side you can observe the gang is separating in the another container. Okay, so for example, this method is used for the concentration or separation of a zinc blend, that is zinc S, ZnS, and copper pyrite, that is CuFeS twice. Now next method is of concentration of ore is a leaching method. So leaching is a process where ore is treated with desired chemicals to convert the desired or required metal within insoluble salts while the impurity remains insoluble. So the required metal will be separated from the impurities by leaching. And the first step in the extraction of metals like aluminium, gold and silver from their ores is a method of leaching, and that means the gold, silver and aluminium metals are treated with some chemicals so that the impurities will easily dissolve in the chemicals and the required metal will be separated. So in this method the ore is soaked in a certain solution for a long time, and the ore dissolves in that solution due to the specific chemical reaction, and the gangue however does not react and therefore does not dissolve in that solution, so it can be separated. And for example, the concentration of bauxite, the aluminium ore, so bauxite is the aluminium ore and is done by leaching method, and here the bauxite is soaked in the aqueous solution, that is sodium hydroxide, or the aqueous solution, that is sodium bicarbonate. And so that the bauxite ore is soaked in these two solutions, and which dissolve the main ingredient aluminium. So here the required metal will dissolve in the solution, and the impurities or gangue cannot be dissolved in the solution. So the impurities can easily separated by this method. Okay students, I hope you all have understood this lesson. That's it for today's video, and next part of the lesson we will continue in our next session. Thank you.